Intelligent buildings are becoming the norm for new facilities and retrofits, and the merger of data and power over low voltage IP cabling for building systems naturally leads to a merger of professions and cooperation between low voltage and electrical tradespeople. Welcome to the EBPowerCon session, Strange Bedfellows, Electrical and Low Voltage Contractors Working Together, with Carol Everett Oliver, current president-elect for BICSI and the principal of CEO Communications, an information and communications technology consulting firm. We'll learn more about Carol as we get into the presentation. Meantime, I'm eager to hear how, instead of being anxious about the convergence of technologies, electrical contractors can and should embrace the opportunities that come with smart buildings and retrofits. And joining us now at EBPowerCon is Carol Everett Oliver. Carol, thanks so much for joining us, and please take it away.
Oh, great. Well, Anthony, thank you for asking me to join in on this session, because I've got a lot of interesting things to talk about, especially on the electrical side of the business, what's going on. So I've got a bit of a presentation, and then I'll tell your audience a little bit about myself. But right now, the title slide says Strange Bedfellows, Electrical and Low Voltage Contractors Working Together. And I know that's a funny title for this, but it's really, really important because, they are strange bedfellows. We're now seeing, the professions actually coming together and working together, and I'll get into why and what are some of the trends in the marketplace, because I'm more from the low voltage side, but I've found myself working on the electrical side as well. Because here's the deal. Before the internet, there were phone installers, IT managers who were pretty much just computer geeks, working with your computers, and the computers were all siloed, and electricians. So then what happened, the phone and data communications merged and became cabled with the same cabling, and so it became telecommunications. And so contractors were then called low voltage contractors, to separate them from electricians who installed line voltage and AC power. But now we're seeing a transition that a lot of devices are being powered over the Ethernet, so it's called PoE. So a lot of the power is becoming DC power, but we're seeing a lot, as I mentioned before, the profession starting to overlap, and the education needs to overlap as well. And these people need to be bedfellows. They actually need to start working together. And I just want to say a little bit about myself. Who am I? And I've been in the ICT business for 25 years in the industry. I have my own business now called CEO Communications, where I do a lot of everything from technical writing to presentations to I even, put out customer contracts, and I do contractor training as well. And this has all basically been in my background. I've worked for several manufacturers such as Tech and Legrand and Siemens Company. So this is where I get my experience, and I went out on my own a couple of years ago and having a great time with it. I've also presented at a lot of industry conferences such as BICSI and ASIS, and even at IEC, which is the Independent Electrical Contractors. I've presented twice there. So it's been really fun seeing a lot of the crossover. As far as the BICSI, so BICSI is the association for the ICT industry, and I serve on the board. I've been on the board in various positions since 2012, starting as the region director for the Northeast, and moved my way to the secretary of the executive board, and I'm currently the president-elect. And in 2022, 1 year away, I will become the first woman president of this association. This association has about 17,000 global members, so I'm very excited about that position coming up. So, you think that electrical contractors and low voltage contractors are really, really different. They're not that different. They're very similar in nature and similar, but where the differences are, for example, electrical cable. One of the things, especially when I train contractors, is, in electrical contractors, they can take the cable, the electrical cable, and staple it on the, staple it, and that's a big no-no with a twisted pair cable, because of course you're going to disrupt the performance of that twisted pair cable. So there's other things and other differences, but in essence, they're sort of doing the same job. You know, they're connecting something. And for electrical contractors, they're connecting the electricity. For low voltage contractors, you know, they're connecting the cable so the data gets through. But now we're seeing a lot of merging with power over Ethernet. You know, and as far as the tools, when you look at a tool belt that these guys are both carrying, guys or gals, it's very much the same: cable strippers, screwdrivers, but yet the low voltage contractors have to have, you know, other tools such as punch down tools or even fiber splicing equipment. So let's take a look at the outlets. Okay, there's definitely a difference in the outlet and what the outlet does. So what's interesting is they're both located 15 inches above the finished floor more often than not, but you're starting to see the outlets being located closer to where the devices are. So think of where security cameras are, or access control, or wireless access points. So we're seeing, you know, the devices actually being closer to where, I mean, the outlet closer to where the device is. So, and also, if you look at the architectural plans, they know which one indicates an electrical outlet and which one indicates where a low voltage outlet or a telecommunications outlet needs to be located. Also, it's important to note that electrical cables have to be kept at a proper distance from telecommunications cables for fear of interference on the data cables, where the data cables pose no threat to line voltage. It does work the other way around if there's interference coming off of electrical high voltage cables. Okay, now we have to play by the rules. So how do we, and what does that mean, playing by the rules? So both electrical contractors and low voltage contractors need to get their work approved by what's called an AHJ, which stands for Authority Having Jurisdiction, and to make sure that those products are installed correctly and safely. So the AHJ can be anybody from a fire marshal to a building inspector. So, you know, electrical contractors pretty much live and breathe the code, whether it's the Canadian code, you know, CEC, CSA, or whether it's the NEC code, which is in, you know, North America. But the codes are written for safety, to make sure that the equipment is safely installed for the equipment and also for the safety of the people that are operating the equipment. So the other acronyms that you see on the electrical contractor side are pretty much, you know, associations and unions. Same thing with low voltage contractors. Now, low voltage contractors do have to abide certainly by the code, because that is enforceable by law. But then there's a lot of standards out there that tell them, you know, how to lay out the networking scheme, how to install the cable, what cable should be used for what applications. So they follow industry standards, which are really best practices. And these are set by the associations such as TIA, ISO is the international standard, and BICSI. So, and for all, these products that are installed must be complied by the code and also become UL listed to make sure that they're safely and that they work correctly. So let's move on to what we see happening in this industry. So what we're seeing is the convergence, and we're now seeing intelligent buildings. And you're seeing a lot of these intelligent buildings being built. And what that means is that you're going to have multiple applications that are integrated over a single cabling infrastructure, meaning the network. So this is how an intelligent building, so now this is operated. So let's say security is now cables to integrate with your access control. And also you have remote operation of these applications. So this creates a lot of advantages to the building owner in many aspects, not only through cost savings, but also energy efficiency, you know, and being able to monitor the load and the function of all these devices. So what are we seeing as we move forward? So this intelligent building trend was actually booming before COVID. And then COVID comes in and pretty much shuts down a lot of the construction, because what did we see? We see a lot of the workers and students now going into their homes. So right now it's pretty much been put on hold. But what we're also looking at is at that time, architects and system designers are looking at taking that opportunity to say, hey, when we go back into the offices, we're going to see it being a little different, and we're probably going to see a lot more implementation of intelligent buildings. So here's a slide of what we probably will see as we move back into the offices. Now, I'm in the United States right now. In fact, I'm in Florida, so we've already opened up a lot of, and it varies from state to state, but in Florida, it's pretty much wide open. And right now in Canada, sorry guys, not so much. Sorry about that. But what we'll see in both Canada and the United States is we'll see a development of, touchless voice-activated applications. We want to make sure that we keep the workers and the people who are now going back to the schools and the offices. We want to keep them safe, and we want to be concerned with their well-being. So we're going to see a lot of sensors employed. And the reason for more sensors is to do occupancy sensoring, also to be able to control the lights and the HVAC if somebody walks in the room and has pre-programmed their preferences for their temperature or their lighting. So what you're going to see now is a lot of convergence of the electrical contractors and the low voltage contractors. And I'm actually seeing a lot of the electrical manufacturers, such as Leviton, provide control of these systems and having mobile apps to be able to control and to set these preferences. So this is what we're seeing, going forward, that we'll see a lot more of this going into these buildings and into the schools as well. So let's take a look at the cable. So, all of these systems have previously had proprietary cabling. Now, if we're moving into an intelligent building scenario, we're going to see that a lot of these applications to be connected to the network are going to be running on what's called IP cable. So that would either be fiber or twisted pair copper. So moving on, what does that mean? So what it means is we're now looking at powering these devices through power over Ethernet. And what does that mean? You can't just plug a device into an outlet and expect it to work. You now have to have certain pieces of equipment so that power over Ethernet does get supplied through the data cabling to the end device. So you have to have a source equipment, and you have to have, obviously, a device. So what we usually see is that the power over Ethernet switch has both the power and also the data, and it travels through the cable, through the Ethernet cable, to the workstation outlet, or it can be directly attached to the device itself. So it can be either connected through a patch cord, or it can actually be attached directly to a plug, and that was called an MPTL attachment, because we realized that sometimes you don't want to have these patch cords visible. So the power over Ethernet will talk to the end device, and it will say, yes, I see you, and how much power do you need, and I will supply you to the power. So it's a change world, because what we're seeing now is, as I'm putting up on the slide now, is we're looking at, we have to have standards that look at power over Ethernet. So there is a standard out there, because power over Ethernet has grown quite a bit. So it started way back when with IP cameras back in the late 90s. And, these were used over the data cabling. And what happened is it was only being transmitted, the power over 2-pair. And as we needed more and more power for the devices, we needed to use all 4 pairs. So now you see it almost like writing over the same data cabling. So you can see the progression of power over Ethernet. You can also see that more and more devices have been added as there's more and more wattage that are needed for these devices. What I want you to pay particular attention to is how much power is going from the source to the device. And that's going to become very, very important, because you're going to see a lot of that evolving. What you're also going to see what could be affected is the current per pair, because you don't want to max out that current per pair, because one thing you don't want to do is have too much current going through that cabling, because that could be disastrous. So we have these power over Ethernet standards in there to say, what limitations are, for the power, for utilizing power over Ethernet. So I'm going to show you a little example of power over Ethernet on the next slide. So as we look at commercial building applications, and this slide has animation in it. So I'm going to show you, how this is going to make a difference. So the power over Ethernet, so all these devices are now powered with data cabling. So if I press forward through this, you'll see LED lights. There's 389 of this. This is a 25,000 square foot facility. And as you push forward in the animation, you can see how many data telecom ports there are, how much display signage there is, and occupancy sensors and wireless access points, even shade control. So this slide has animation in it, and you fast forward through it, and you can see all of this is populated. So this is all through data cabling. This is not through being electrically attached. So this is where you see a lot of these installers and electricians working with low voltage installers working together. So now it used to be where low voltage was kind of an afterthought. Well, we need to put in a couple of outlets there for our computers, but now you see how many applications are going to be running over low voltage. So now you're seeing the electrical and the low voltage contractors sitting down to the table way before the building is cabled or before it's even completed. So this is where we see a lot of overlapping of what's going on, building contractors working together in this. And this is where I get it called strange bedfellows. Anyway, but there are some issues with power over Ethernet cabling. As you saw from the previous slide, you have to be careful with how much power does the device draw, how much power is going through that cabling, because the last thing you want to do is have that cable overheat, and that could create a major problem such as a fire. So there is a temperature rating of the cable that you need to be aware of. Also, the bundling of powered cables, because as heat goes through it, so there are recommendations to have smaller bundles in the cable tray. And then also, one thing that the electrical contractors know a lot better than the low voltage contractors is that you need to have larger gauge, because the larger the gauge, the larger the copper is, the better for heat dissipation, for that whole run through the cable. So that's going to become, very important. So it becomes really, really important to see the contractors working together. When it comes to an intelligent building, it's so important for both electricians and low voltage contractors to come to the table way in advance to understand the power and the data needed for all the applications in the building. So, whereas low voltage cabling, also known as computer cabling, was an afterthought for a building, it now becomes really important to have this planned out way in advance. So power and data are now obviously coexisting on the same cable. And I can only see more and more devices happening in this realm because of power over Ethernet technology. So this means that there's going to be a lot of challenges and a lot more teamwork between the electrical contractors and the low voltage contractors. And no one is expected to memorize all the codes and standards. So as long as you're aware that these documents exist and where you can find these documents. Also, sorry about that, I'm looking for my clicker. But as long as you're aware that electricians and low voltage installers really need to work together and become cross-trained. So here's where I see that working together is going to create a lot of opportunities. So what are the next steps for both low voltage contractors and for electrical contractors? So there's opportunities for both. There are classes and resources out there to get your hands on. Cable and connectivity manufacturers, as well as distributors, offer training and certification courses. There's a lot of, I see a lot of co-partnering between associations, and it's very important. I see a lot of electrical contracting companies partnering with low voltage contractors, and even having a different division now called low voltage and then electrical as well. but nothing can compare to on-the-job training. So I think that's really important too, to maybe shadow a low voltage contractor or vice versa. Right now, in the COVID times that we're living in, there are a lot of virtual classes and webinars that are free. And once we get over all this COVID stuff, make sure that you attend trade shows and conferences like the one that you're attending now virtually, but hopefully we'll be back in person again so that we can, do more hands-on with each other. So my last slide, I do have to bring in the importance because I talked about cross-training. So I thought I'd mention the credentialing and professional development offered by BICSI. That's the association for which I sit on the board and I've been involved in for a long time. Because BICSI offers a lot of installation programs and credentialing. Electricians can take some of these courses. You can take them from vendors. You can also take them through the BICSI association. And probably the best word of advice is to, when you want to get involved in low voltage, is but purchase the installation guide, because that covers both copper, and fiber, which has all sort of been smoke and mirrors to a lot of the electrical contractors and those of us who deal more with the copper side versus the fiber side. But they're great resources. Also, the classes will teach about pathways and other critical elements, because the pathways for electrical and low voltage cabling are completely different. There are a lot more, unfortunately, there's a lot more rules with the low voltage cabling. And even if you don't want to get a credential, the education is certainly worth the investment. So that's my story. So like I said, I have my own business, but I'm also on the BICSI board. So I'm available either way. I'd love to be able to help your audience.
Carol, thank you so much for joining us at EBPowerCon to provide this overview of smart buildings and the convergence of technologies, and for highlighting all the various venues and places where professionals can find more information, education, and training. It's truly appreciated.
Anthony, I really appreciate you giving me the time today.